Hi everyone, welcome to all 4C learning classes. This is Zoology Chapter 3, Session 12. Blood coagulation is the process which includes the three overlapping mechanism, which includes the vasoconstriction, formation of platelet plaque, and the formation of web of fibrin proteins is what we have seen. And I told you that the blood coagulation or blood clotting is a cascade reaction. Cascade reaction is a process where one step of a reaction influences the next, that influences the next, that influences the next, that influences the next. Which means if it is breaked at any point of a time, then it doesn't take place. So that's the reason why it requires series of the physiological mechanism. That's what it is, a cascade reaction. This blood coagulation, how it is a cascade reaction, now we'll see. First, step 1. Step 1. Prothrombinase formation. Prothrombinase. Or else prothrombin factor, prothrombin activator formation. So as I already told you that it is a series of the reactions where one step. So in order to convert the second step called prothrombin into thrombin, prothrombinase activator is needed. So the factors, generally there are 13 factors are involving in blood coagulation process. There are 13 factors. In terms of number they will come to 12, but the 13 we consider. The due reason is sixth one is hypothetical, it is deleted. That's the reason 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13 factors. Now we'll see those 13 factors, as here we need to discuss the factors involvement here. So blood clotting factors are, there are 13 factors that are involved. First we'll discuss that. The blood clotting factors, if you see, Factor 1 is none other than the fibrinogen. Fibrinogen is considered to be the factor 1. Fibrinogen. Next, factor 2 is prothrombin. Recall your memory that we discussed prothrombin and fibrinogen are the factors synthesized in the liver. So liver, with the influence of vitamin K, it synthesizes the prothrombin factor. So vitamin K, what do we name vitamin K? It is a blood clotting vitamin, anti-hemorrhagic vitamin. Hemorrhage in the sense rupture of the blood vessels and loss of the blood. Is that in a blood coagulation process the blood vessels are ruptured? No. Generally, however injury takes place, but blood loss do not takes place. Loss of the blood is hemorrhage and bleeding. That is prevented by vitamin K. Hence it is a anti-hemorrhagic vitamin or blood clotting vitamin. So vitamin K influences the liver for the synthesis of the factors 2nd, 7th, 9th and 10th. Now we'll see those factors. Factor 1 fibrinogen, factor 2 prothrombin, and factor 3 is thromboplastin. Thromboplastins are of tissue thromboplastin and the blood thromboplastin, which means if an injury takes place to the blood vessels, so thromboplastin, if the tissues are extracellular vascular tissues if damaged, means Tissues associated by blood vessels, if damaged, those are tissue thromboplastins. Plasma thromboplastin, tissue thromboplastin. It comes under the factor 3. Next, factor 4. The factor 4 is factor 4, calcium ions. Calcium ions also play a vital role in blood coagulation. Factor 5 is said to be the proaxelerin. It is said to be the next. Factor 6 is deleted. It is hypothetical. It is deleted. So I am writing deleted means it is not at all involved. Understand? It doesn't mean that deletion is one more factor. Don't think in that way. Factor 6 is hypothetical. And factor 7th we go. Factor 7th is what's it to be the proconvertin or stable factor. It is said to be the stable factor. Next, factor 8 is said to be the anti-hemophilic factor. AHF stands for anti-hemophilic factor. Hemophilic factor A, or else it is also named to be the anti-hemophilic globulin AHG. Next, factor 9th is named to be the Christmas factor, or else it is also named to be the plasma thromboplastin component. PTC stands for plasma thromboplastin component. Or else it is also named to be the anti-hemophilic factor B. Next, factor 10th. Factor 10th is named to be the Probus Stewart factor. Factor 10th. Factor 11th. Factor 11th is, it is considered to be the anti-hemophilic factor C, or else plasma thromboplastin antecedent. I repeat, here PTC stands for plasma thromboplastin component, PTC component, whereas PTA, plasma thromboplastin antecedent is what we consider factor 11. And factor 12. Factor 12 is being the Hedgeman's factor. And factor 13th is considered to be the Fibrin stabilizing factor. Stabilizing factor. So these are all what we treat it as the 13 factors involved. I repeat, 13, where the 6th one is hypothetical and it is deleted. Factor 1 is being the fibrinogen, factor 2 is prothrombin, and factor 3 is being the thromboplastin, Factor 4, calcium ions. Factor 5, proaxillerin. Since it is pro in the sense before. What before? Before axillerin, that's what proaxillerin. The sixth is deleted, hypothetical. Factor 7th, proconvertin or stable factor. And the factor 8th, anti-hemophilic factor. A, anti-hemophilic factor, anti-hemophilic globulin is also what we considered this, the 8th one. Whereas the 9th is Christmas factor, plasma thromboplastin component. PTC stands for plasma thromboplastin component, or else it is also named to be the anti-hemophilic factor B. And factor 10th is Prover's or Stewart factor. Factor 11th, anti-hemophilic factor C or PTA, plasma thromboplastin antecedent. Factor 12, Hedgeman's factor. Factor 13th is fibrin stabilizing factor. So there are terms what we came across is a factor 8 is anti-hemophilic factor A, and factor 9th is anti-hemophilic factor B, and factor 11th is anti-hemophilic factor C. What do you mean by this? You mean that they prevents the hemophilia, that's what anti-hemophilia. What do you mean by anti? Stands for against. Anticoagulant, it is against the coagulation, so anticoagulant. Heparin does not allow the blood to clot, so anticoagulant. In the same way, anti-hemophilic factor, in the sense, this is a factor which avoids the hemophilia. What do you mean by hemophilia? Hemophilia in the sense the blood loss. So it is preventing blood loss. Bleeder's disease is hemophilia. As it prevents the hemophilia, so it is anti-hemophilic factor. That's what anti-hemophilic factor. So these are the 13th factor we came across, and they are going to be influencing in the blood coagulation. That's what the 13 factors now playing role in blood coagulation. In that connection, first we'll go for the step 1 prothrombinase or prothrombin activator. Prothrombin activator. The first step involves prothrombinase formation or prothrombin activator. As we discussed, it is a cascade reaction where one step of reaction influences the another. So in this, the first step is prothrombinase or prothrombin activator formation. Prothrombinase activator. Prothrombin activator is nothing but the one which act upon, which makes the prothrombin activation. That is none other than prothrombinase, an enzyme which acts as a catalyst in conversion of prothrombin into thrombin. That's what the first step. This is what involves the two steps it involves. The two pathways are involved. The pathway, there are two pathways involved here. Two pathways. One is a intrinsic pathway. One is intrinsic pathway, and the another is extrinsic pathway. Extrinsic pathway. One is intrinsic pathway and the another is extrinsic, which means one that is if injury to the blood vessels are internally takes place. So certain times what you find is internal bleeding occurs, that is not externally seen. So intrinsic pathway is initiated by factor 12. Factor 12, Hedgeman's factor, which means when injury takes place to the blood vessels. So collagen fibers exposed to the blood, and this injured blood vessel collagen fibers when exposed to blood, this activates the factor 12. This factor 12 activates the other factors. First, injury. What causes the release of collagen fibers? These collagen fibers stimulate the factor 12. This factor 12 influence or stimulate the other factors to synthesize prothrombin activator. So intrinsic pathway is nothing but the injury to the blood vessels. When an injury to the blood vessels, collagen fibers released exposed to the blood. This activates the factor 12, which is a Hedgeman factor, factor 12, and that activates the prothrombin activator. So prothrombinase synthesis also involved a series of events influencing one to another. This is how the factor 12 influencing the prothrombin activator. Next, extrinsic pathway. When vascular tissues, what do you mean by vascular tissues? That is the tissues, the body parts, organs that contain tissues if get an injury. When you get an injury, certain times the blood comes out. That is vascular tissues. But certain times internal bleeding, internal damage, but that doesn't be seen externally. So extrinsic pathway is an injury to the vascular tissues. What stimulates the synthesis of thromboplastins? These thromboplastins stimulate the factor 7th. What is the factor 7th? Nothing but the proconvertin, or else the stable factor we have seen. That 7th factor influences the other factors to synthesize a prothrombin activator or substance prothrombin activator. So this is the first step where prothrombinase formation or prothrombin activator formation. An injury to the blood vessels release the collagen fibers that expose to the blood, which activate the Hedgeman factor, that activate the other factors to synthesize prothrombin activator, which is an intrinsic pathway initiated by factor 12, and the extrinsic pathway is initiated by factor 7. How? An injury to the vascular tissue release the thromboplastins, tissue thromboplastin, that activate the factor 7th, that activate the prothrombin activator. This is how the first step. Second step, step 2. Step 2 involves the conversion of prothrombin into thrombin. Second step. This is the second step. Prothrombin conversion into thrombin. Basically, you may raise a doubt, sir, this prothrombin and fibrinogen are present in the blood, then why not blood clotting? Basically, the prothrombin is an inactive form. It is the early form of thrombin. Until and unless the prothrombin convert into thrombin, the blood do not clot. Fibrinogen is also in an inactive form. So there need to be activation. So for that, the prothrombin activator is released before the preceding step. So once the prothrombinase or prothrombin activator is synthesized, it converts the prothrombin into thrombin. Prothrombin into thrombin. In presence of prothrombinase or else prothrombin activator, it converts the prothrombin into thrombin, where calcium ions also play vital role. Basically, calcium is an ion which comes under fourth factor we have seen. Fibrinogen, prothrombin, thromboplastin, calcium ions, proaxillerin, proconvertin, antihemophilic factor A, Christmas factor, Stewart factor, antihemophilic factor A, or else anti-hemophilic factor C, or else plasma thromboplastin antecedent hegemon factor and fibrin stabilizing. 5, 5, 10 plus 3, 13. So the calcium ions are the fourth factors, which in presence of prothrombinase convert the prothrombin into thrombin. Now step 3 is the released thrombin. The released thrombin act upon the fibrinogen fibers. Fibrinogen, which is in inactive form. Fibrinogen. The thrombin act upon the fibrinogen and convert into fibrin fibers. Fibrin fibers. In fact, the fibrin fibers are formed in a soluble state itself. Soluble state. The fibrinogen, in presence of the thrombin, fibrinogen is converted into active fibrin. These fibrin fibers formed are still in a soluble state, dissolved state. It needs to become insoluble. For suppose, if I take a glass with water, here I added the salt, here I added the sand. So now answer, this is not absolutely a water, it is with something else, but is in a soluble state. Is it right? But here sand is up here. So in the same manner, here you need to form the clot, for which the fibrin fiber needs to become the insoluble. So thrombin act upon the fibrinogen and convert into fibrin fibers. Now this fibrin fiber is in a soluble state and are also with the hydrogen bonds. Hydrogen bonds. Basically, the bonds are hydrogen bonds and covalent bonds, in which the covalent bonds are stronger. So, as a next step, the fibrin stabilizing factor. Fibrin stabilizing factor is released, which act upon the soluble fibrin into insoluble fibrin. At the same time, the insoluble and hydrogen bonds are converted into hydrogen bonds are converted into covalent bonds. Covalent bonds. So here the bonds between the fibrin fibers, the fibrin becomes stronger. This is how all the fibrin fiber become the come closure and are what stick with each other with the strong bonds called the covalent bonds. And all this fibrin fiber network come closure and forms a web of the fibrin fibers. A web of fibrin fibers, and it reaches the what is called a injury or wound, where it dilates and attaches to the injured wall surface and fix it to it. After fixing the injured wall, the clot what become closer, or else it become constricted. Right? So once it constricted, some fluid was released, which is named to be the serum. I repeat, as a third part, the fibrinogen in presence of the thrombin converted into fibrin fibers. Still they are in a soluble state and are with the hydrogen bonds. It needs to be converted into the stronger bonds called covalent bonds, and it needs to be become the insoluble. So the soluble fibrin fibers in the action of, by the action of fibrin stabilizing factor. What is a fibrin stabilizing factor? It is a factor 13, factor 13. This factor 13 converts the hydrogen bonds in between the fibrin fibers monomers into covalent bonds. They become stronger and all the fibrin fibers come closer. It becomes a web. So some spaces are what are left. When you even fold this, some spaces are seen. The same way all the network of fibrin fibers leave some spaces where the blood cells are stick. And this is how a clot is formed, which closes the wound. Once it closes the wound, it comes closer, constricted. This process is named to be the clot retraction. Clot retraction. Clot retraction. As soon as the clot retraction takes place, the fluid released from this region is named to be the serum. So, for suppose, if you take a sample of blood in a test tube, after 3 to 5 minutes of a time period, a clot water remain at the bottom and the fluid is what's seen above. That's nothing but the fluid present above the clot is a serum. Serum, already I told you, serum is a plasma minus clotting proteins. Is it right? Which means serum does not involve in the blood clotting. So here, once the wound is closed by clot, it retracts, that is, it come closer and pull the walls of the wound closer. So fluid water release, as if when you dip a sponge in a water and if you press it, the fluid comes out. Is it right? In the same manner, the clot retraction release the fluid that is nothing but a serum. Serum is a clot retraction results in a serum. Serum is equal to plasma minus blood clotting factors. Blood clotting factors. Right? So this is how the blood coagulation takes place. And in which the 13th factor, where what we have observed is one step of a reaction is influencing the another. Step 1 influencing the step 2. Step 2 influencing the step 3. That's what it is, a cascade reactions. And this is how the blood loss is prevented. Entry of microbes also prevented. This is the story about the blood coagulation, blood clotting. There are certain instances in certain individual, in spite of injury, the blood do not clot, which is said to be the hemophilia, bleeder's disease, and it is the blood loss. It is a genetic disorder, which is a X-linked recessive disorders. Now we'll go on discussing the anticoagulant subtopic. Anticoagulants. Now we'll move on to anticoagulants. What do you mean by anticoagulants? Anticoagulant means that do not allow the blood to clot. The anticoagulant list are 1. Heparin. Next, Coumadin, and Hydrudin, and Lampredin. These are what are said to be the anticoagulant. I repeat, heparin. Heparin is an anticoagulant synthesized by liver itself. Liver synthesizes the anticoagulant. In fact, what we see is it's a connective tissue. Among the connective tissues, the mast cells and the basophils. What we learn is the basophils and the mast cells are what the cells present in the connective tissues are what are synthesizing the liver as heparin and anticoagulant. They are the part of the connective tissues. That's the reason why we discussed it. Basophil is a supplementary cells of the mast cells. Mast cells synthesize bradykinin, histamine and heparin. In the same way, basophil also synthesizes the heparin. Heparin is an anticoagulant. It does not allow the blood to clot. which means it activates the antithrombin, which binds with the thrombin and make it inactive. Once the thrombin inactive, is that the fibrinogen converts into fibrin? No. So blood do not clots. That's what it is an anticoagulant heparin. The second one is comedin. Comedin is nothing but of a plant origin, which is present in the form of precursors called the warfarin in the plant origin. Hydrodin. Hydrodin is said to be hydrodin. This comedin is of plant origin. It is present in the form of precursors of warfarin. It is said to be. Precursor means early form. I already told you. Vitamin A in a plant substances in the form of beta carotene, which is when taken in liver, this beta carotene converted to form the vitamin A. That's what we see liver synthesizing the vitamin A in that way. So precursor means early form. That is a fibrinogen. Fibrin whose early form is fibrinogen in the same way. So comedin. Next is hydrodin. Hydrodin is present in the saliva of the leeches. Basically, what do we know regarding the leeches? Leeches are said to be the swangivorous animal. Swangivorous animal. Swangivorous. Vorous means what is called taking. Swangivorous, larvivorous, frugivorous, granivorous, likewise we say. You know very well larvivorous. Gambusia of Sinis is a fish which feed on the larva of mosquito. That's what larvivorous. So here swangivorous, blood sucking and taking. Leech, blood sucking animal. However, one more is also there. The mosquitoes. Mosquitoes are also the blood sucking. So when an injury takes place, so far we have discussed, when an injury takes place to the blood vessel, immediately blood clot based on the intensity of the wound. So when the leeches suck the blood, mosquitoes suck the blood, immediately it get clot. So they need to produce the anticoagulants. Here the leeches hydrodin, which releases into saliva, which is released into the wound. So this does not allow the blood to clot. So blood can be squeezed by the leeches hydrodinuria granulosa. In fact, that is the reason why it got the scientific name, hydrodin. Next, lampredin. Lampredin is secreted by a cyclostome, named to be the lamprey, petromyzon. Petromyzon is also we have already learned in first year, cyclostomata. Anathans are cyclostomes, extant jawless member, petromyzon, which is also named to be the lamprey, and this is also what leading the swangivorous nature. It is ectoparasitic and suck the blood from the other members. So for that, definitely as soon as the blood comes out, it get clot. For that, it releases the lampredin and it does not allow the blood to clot and takes the blood. So these are what we consider the list of the anticoagulants, which does not allow the blood to clot. And even the hemolysin from insects, that is none other than the hemolysin, nothing but the mosquito. That also release the heme means blood, lysin means breaking. As the blood do not clot, so mosquito go on sucking the blood. So these are what the list of the anticoagulants. Next, apart from that, you might have been to the laboratory, where in order to test your blood, if your blood is taken, what happens? Just now I told you, when the blood is taken in a test tube, what you find is, after a certain time, 3 to 5 minutes of time, the blood get clots. It is a natural property. This is a clot. And this is what? Serum. So blood get clot. So how do the preservation of the blood takes place in the laboratories? This is done by means of calcium removers. Citrates and the oxalates. Citrates and the oxalates of the sodium. Citrates and oxalates of the sodium in a laboratory are added to the blood. For suppose a blood of a person is taken, it is immediately added by citrates and oxalates. What happens? Calcium is one of the factors. Fourth factor is a calcium we discussed. Calcium in presence of the prothrombinase convert the prothrombin into thrombin we discussed, which means calcium play vital role in blood coagulation. So, if calcium is removed from the blood, what happens? Prothrombin is not converted into thrombin. So, all what we say is the sequential physiological overlapping mechanisms, cascade reactions are stopped. If any of the step is stopped, what happens? The next step is not done, right? So, the citrate and oxalates, when added to the blood, what happens? It results in the consequences are calcium oxalates and calcium citrates are formed. Is it right? Calcium oxalate and calcium citrate. Generally, every element loses its property when it is a compound form to normal form. As long as it is a calcium, it is a blood clotting activator. Blood clotting is done or else it is taking place. When calcium is removed, when the oxalates and the citrates are added to the blood, calcium oxalate and calcium citrate is formed. So it become a compound, means calcium is removed from the blood. And the blood remain in a fluid state, and this is how in blood banks the blood is preserved. So this is a calcium remover. As the calcium removers are. So you may be asked a question. If I ask you a question, a statement, calcium removers are used in the blood banks. A statement, is it true or false? Yes, true. And what is the reason for it? The oxalates and the citrates, which are said to be the calcium removers, used in the laboratories, blood banks, as the calcium removers called citrates and oxalate remove the calcium from the blood. So blood clotting is prevented. This is how the calcium removers called citrates and oxalates are used in the blood bank for the preservation of the blood. Understand? And besides that, EDTA, ethylene diamine tetraacetic acid. EDTA, ethylene diamine tetraacetic acid, is a water also said to be used for the removal of the calcium and for the storage of the blood in the laboratory. So, anticoagulants and the calcium removers. Anticoagulants are heparin, comedin, iodine, lamprey, and the calcium removers are citrates and oxalates in the laboratory, a clinical pathological department, where in order to find out, for suppose if the blood get clot, how the blood testing is done, first point. And second time, when it is preserved, if the clotted blood is of no use, so in order to remain it is in a liquid form, these calcium removers are added which remove the calcium. So blood remain in a fluid state. Generally, blood donation can be done for every 3 months or a period of time from the healthy blood donor. It can be done as every 120 days of a lifetime, and then WBCs of certain few hours to few days, they are what become old and are worn out. So every 3 months if it is done, it is of no problem. For that reason, blood donation is done. The donated blood is preserved in the laboratory by using this citrates and oxalate as well as EDTA, ethylene diamine tetraestic acid. This is in the laboratory for the storage of the blood. And one more is the vitamin K. Vitamin K is said to be, vitamin K is a blood clotting vitamin, which is the anti-hemorrhagic vitamin which allows the blood to clot. Means it have an indirect role, that is, it stimulates the liver to synthesize factor 2, factor 7th, factor 9th, factor 10th, factor 10th. So the vitamin K is a coagulant vitamin which stimulates the liver to synthesize factor 2. What is factor 2? Prothrombin. 7th, proconvertin. 9th, Christmas factor or plasma thromboplastin component, and the 10th, Stewart's proper factor. So these factors are involving in blood coagulation. That's what vitamin K role in blood coagulation. Thank you.